Okay, so I don't think it's controversial to say that Ruby hasn't really been in the generative AI conversation. We haven't. But I think that's a real shame. And it's a real shame not because we're not getting official SDKs from all of the providers. We can write our own SDKs. We've been doing that for years. It's a shame because the Ruby mindset and the Ruby approach to programming isn't being represented in the experiments people are doing as we're trying to figure out how to actually interact with this new technology. What new applications are we going to be able to build? How is it going to change how we build applications? And to me, I'm worried that we're going to end up back in the dark ages doing whatever we were doing before Rails, and I don't want that to happen. So my name's Scott, and this is my talk going Postel. So I mentioned experimenting, and one of the techniques I've found that's really helpful when experimenting with something new is to take a principle you know very well and apply it to the new domain and really push on it, take it to the extremes, try it, and look at everything through that lens. And so we're going to do that today with Postel's law, which says that you should be liberal in what you accept and conservative in what you send. And so as I was preparing for this presentation, I realized another way to really live that principle would be to generate my slides live for my talk using PowerPoint Copilot. Let alone how terrifying this is going to be. So bear with me here. And so I'm going to ask all of you to also be very liberal in what you accept here from this talk. And I will promise to be very conservative in what I send to the LLM to try to make this work. So let's get going. Let's see if we're going, looking things over. Almost there. And there we go. Okay, so it's going to work. So like I said, Postel's law is summarized as be liberal in what you accept and conservative in what you send. And this was a principle coined by John Postel in the early days of the internet, early days of networking, as everybody was trying to figure out how to actually build networked applications. They didn't know all the things we know today. And so this principle was important for starting to build more robust applications, build more robust applications that are networked. And you can also think about it, it's also known as the robustness principle. But you can, the details of it were basically that if you're going to write a program to send messages out on the network, you should do everything in your power to conform to the spec. But if you're writing applications that are going to receive messages on the network, and you get a message that doesn't exactly conform to the spec, but you can determine the intent, just let it through. Just do what that person was trying to do. Because none of us know how to build networked applications. This is all new, so take it easy. And I think this is a very important principle for LLMs, but it's also something that us as Rubyists know very well. It's something us as Rubyists know very well because there are a lot of features of Ruby and the culture of Ruby that if you look at it a certain way, you can see it as being inspired by Postel's law. So things like duck typing, where the types don't actually matter. As long as the thing that it has responds to the messages you send it, Ruby's fine. Ruby is very liberal in the types that you send it, as long as as long as it responds to those messages. A lot of us here are probably familiar with hash with indifferent access, which is another example of building tools in Ruby that are Postelian, right? That this hash with indifferent access lets you access hash keys or hash values using string keys or symbol keys. To me, that strikes me as a very liberal hash implementation. It's at least twice as liberal as most other hash implementations I know of. And then finally, like Ruby's focus on programmer happiness and how that's implemented. So when I was first learning Ruby, a lot of the advice that you would get was don't even bother looking at the API docs, just call a method, and a lot of times that method will exist. And that's accomplished because a lot of libraries, and even Ruby core libraries, have multiple different ways to do things. And so to me, that strikes me as Ruby, the language, is very liberal in the way that you want to build the program, and it's conservative in that it does what you want it to do. And so, like I said, this is a very important principle when working with LLMs because these things are non-deterministic, that they hallucinate. And so there's a lot of work going on in the industry right now to try to constrain the output of these things and make sure that the output from the LLM is exactly right. But that strikes me as a very conservative in what you accept kind of approach. And I think there's an opportunity to take the Ruby philosophy and the Ruby mindset, the thing that we know very well, and turn that on its head. So instead of making sure the output of the LLM is exactly what you want, we can build our programs so that whatever the LLMs give us works. So a little more liberal in what you accept kind of approach. And Ruby has a lot of facilities to build programs that way. All of us are familiar with, metaprogramming, dynamic dispatch, extremely virus. Like I said, liberal in what you accept here. Dynamic dispatch, reflection, all of these things, all of these tools, and Ruby's flexibility allows us to build our programs in a new way using this alien virus technology that, that is non-deterministic, and we haven't really had technology that, lies to us before. So with all of that build-up, enough talking, I'm going to show some code examples of how I've taken Postel's law and really pushed on it and come up with some really weird ideas and fun ideas, and how Ruby has made that easy. And yes, what I'm kind of saying is this. So let's get going. So one of the open source projects that we built is this tool called Blueprints, which is a Rails server and an editor plugins where you can capture patterns in your code and use those as a basis for generation. If any of you are familiar with some more of the terms around LLMs, this is essentially like combining it's RAG and few-shot prompting, but in your editor and much more simplified version of that. So what it allows you to do is, like I said, capture patterns in your code. And so here's an example of, you might have an index view, a flex index view for your customer's resource. It's got, a section. It's got a handful of Tailwind classes. It's got an aside. It's got a customer view component and a customer list component. And what you're able to do is you highlight the code, you capture the pattern, it gets sent to the Rails server, a description is generated, we generate vector embeddings, and make it available for you to use later. And so this is baby steps into being conservative in what you send. This is a pattern you want to reuse in your code base. And so say tomorrow, it's like, okay, we need to create an index view for our products resource. So we can go here. You have a description. It might be something you type out. It might be a line in your product management tool. But what you can do is, if you take this and you highlight it, it gets sent to that Rails server. It finds the closest match, and essentially builds a prompt that says, here's a customer index view. Here's what it looks like. Take that customer index view and create a variation of that for my product. And so by being conservative, we were able to generate an entire chunk, a pattern of our code, rather than autocomplete a line. And then not only that, this code doesn't run because it hallucinated the existence of this product view and product list. And so to me, that made me realize that by being conservative in what you send, you can actually target hallucinations to do something that you were probably going to do anyway. The product view, product list components don't exist, but you might have blueprints of the customer view and customer list to go and keep doing that layer by layer. But we can take this further, right? This is just, being lightly conservative. A more conservative approach is testing. And tests, I see tests as a much more conservative approach because these things will either run or they won't. Or here's the specification of what we want this code to do, and they will either run or they will fail, and it's wrong. And so another open source project that we've built is our agent framework, where we're building a DSL for defining agents. And agents have hundreds of different definitions. The ones we're talking about here are kind of like daemons that sit around and wait for triggers in an environment and then do some predefined steps. If you talk to 100 people, you're going to get 100 definitions. But so the way this DSL works is you define a trigger, you define a goal condition, you define a way for it to check its status on its way toward the goal condition, and then you define a way for it to take a step and go through that loop again, take a step, check its status, am I at my goal, etc. And so we built this agent for doing TDD, or test-driven development, with us. And so the way that works is it's triggered anytime an implementation file or a test file changes. The goal condition is that the tests are passing. The way it checks its status is to run the tests and examine the output. And then the way it takes its step is it takes the implementation file contents, the test file contents, and the test output, sends it to an LLM, basically building that prompt and saying, give me the new implementation that passes these tests, take that implementation and save it to the file, which triggers the test to run again, and it goes through that loop. And so let's see it in action here. Okay, so we have this pile spec class and a pile.rb, and we've got the tests are passing, which is questionable, but spec.describe pile, and save that file. The tests run, they fail because the pile class isn't so fast. They failed because the pile class wasn't defined, and the LLM generated the pile class. And so we can take that further of describe add, it adds the item to the contents, p equals pile.new, p.add apple, and p expect p.contents equal. Thank you, Copilot. And there you go. So it was that fast. That test failed. It generated the implementation of that file. And we can take that further, right? We can go say describe remove. It removes the item from the contents. And let's actually change the initializer to, let's say it starts with apple and, or actually starts with apple and banana. And p.remove apple, expect p.contents equal banana. And the tests fail again. We generate it changes the initializer, it adds the remove method, and we can keep going. But as I've been playing with this, I found some very wild things. It almost makes this code kind of self-healing. So say you accidentally edit it, it goes back and fixes that error. But so the other thing that I've realized as I was doing this, as by being more conservative in what you're sending with the tests and actually running them and saying this code is either right or it's wrong, is that you can be very liberal in what you accept back from the LLM. If you're writing really good tests, the code kind of doesn't matter. You might have instead of writing an accessor for contents, might have used attr reader or something, but again, that doesn't really matter. You can continue to write tests to make sure that it's not used in the wrong way, but I think that it unlocks a really cool process and a really cool relationship with the code. But we can take it further, and we can combine those two ideas. Oh shoot, color. Shine. We can combine those two ideas. So say you've bought into this idea of I'm going to store patterns in my code base and use those to generate new code, and it's going to hallucinate things that don't exist. And I'm bought into writing tests and making sure that writing really good tests to make sure that this code works. So, say for example you're working on a chess app. And you've built your rook piece, and you run our spec rook, the tests pass, and the next step is to create the queen. And the queen's probably going to have this same interface. It's going to have a symbol, probably include these modules. It looks like we have this move ders interface for pieces, which the rook calls horizontal ders. And we take this, we highlight it, we store it as a blueprint, which again, this is got a blueprint Rails server running locally that I send this code to it. It generates a description, generates vector embeddings, and makes that available for me to generate new code later. And so the next step is we go to Queen, and we can see that we've already written the Queen tests. And it fails because uninitialized constant queen. And so we follow that process where we highlight this, we send it to the server, it finds the rook piece and generates that prompt of, here is an example of a rook piece in our app, generate me a queen, generate me a variation of that rook piece. And so it did it faster than I could finish talking about it. It's got the symbol, it's got move ders, it used the horizontal ders, but it hallucinated the diagonal ders. The diagonal ders wasn't in that rook implementation. So we save that file, and we can run the tests again, but they still fail, and they still fail because uninitialized local variable or method diagonal ders. And so, we see that failure, and we're like, okay, well, let's see what's going on in Slidable. Slidable defines horizontal ders, but it exposes the diagonal ders through a method called xders. And who knows why that happened? So maybe somebody was trying to be funny one day, and it passed PR review. But you also don't want to go and refactor the entire code base. Maybe there is a really good reason for it. And so Ruby makes it possible to handle those kind of hallucinations because while LLMs are hallucinating, they're still, the intent is still there. And so we can determine the intent of what the LLM meant by this diagonal ders, and Ruby gives us the tools to do that. And so we've created this module to help make that possible. It's very hard to say, I need to come up with a better name for it, but we call it Synonym, which allows you to hook into method missing and allow you to call methods by synonym. So we essentially build anytime method missing is called, we essentially build a prompt of this class just got this message and we don't know what to do with it. Here's the implementation of the class, here are the available methods for this class. Is there anything that might be a synonym of what this person tried to call? And if so, call it. So if we go ahead and require it and include it, moment of truth, and run the test again, the test pass. Whew. It failed a couple times in practice. And so, yeah, right now we're just calling this, but there's a lot of different things that you can do, and Ruby makes possible that you might not exactly want this behavior, but it could define aliases on your class. It could output that to a file. It could output it in your test suite. That, hey, maybe this diagonal dir's name is a better name than xdir's, and the LLM keeps generating all of these things. And so you might not use it at runtime, but you might use it in your test suite to actually help guide you and create better names. Or this might be making a lot of people uncomfortable, and that's fine too. But there are also other types of programs that we write that you don't necessarily need. They're not mission critical. Nobody's going to lose any money. Nothing bad is really going to happen. And the LLMs make it possible to start exploring new ways to write programs that can handle that. And Ruby makes it possible to really explore that and explore that easily. So say you were writing a script. I forgot to do the color on all of these. Sorry. So say you were writing a script really quickly to figure out what day of week a particular date in the past is, and you're just doing this really quick. You don't want to go and look up the API docs because you know that there is a method here for figuring this out. But you can at least write the method with your intent, and oops. Spoiler alert. You run it. Day of week isn't defined on date, and again, you don't have time. You don't want to go and look at the API docs for date and try to figure this out. You can just slap this code together, and Ruby makes it very easy to do that. You can just monkey patch date, and you can add the synonym module to it, and there you go. December 21st, 1995 was a Thursday. So again, I think this is really just like the tip of the iceberg. Pulling on one thread from Postel's law as a guiding principle. But I think there's a lot out there, and it's really exciting that I can, a lot of these ideas we came out of a discussion and we had running code that day to see what this feels like. And that's really exciting because a lot of times really good ideas really sound like very bad ideas at first. And if it takes you days or weeks or months to actually test these ideas out, you just don't try those and you don't find those good ideas. And I think that's really important. And I'm so excited by all of these possibilities and all of this new ways to write code. And they're super excited that Ruby makes that possible because, yeah, here, we're monkey patching our own, or we're including these modules into our own classes, we're monkey patching date. But when we do find those things, to really use those in all of our programs, Ruby makes that easy too. We can add this to all of our code with one line. And yeah, as I was writing this, I had that comment I was going to use wise, put your best practices away, and it auto-completed, I'm going to monkey patch the world, and I thought I needed to keep that in there. Okay, so like I said, this is really just, I think, the tip of the iceberg, and there's so much exciting stuff that's possible that really isn't being explored because just because it's so new and we're kind of just getting started. But I don't know if any of you have ever thought, like, I wish I was around in the early days of Rails or the early days of all the things that we kind of take for granted or using today. That opportunity's back. There's a wide open space for all of your ideas and all of your experiments. And there's a handful of us in the Ruby AI Builders Discord doing that. Tons more experiments. A lot of us have created, hooking into method missing and actually just writing the implementation of the code if we can determine the intent of the class and the method. Experiments around Rails apps with just a 404 route and determining what the controller action should do by the route, the HTTP method, and the parameters. But there's a lot more. There's a lot more, and we would love to have you and love to share your experiments. So I hope this has inspired some of you. Thank you, everybody. This is my talk. All the resources are available at sublayer.com going Postel, and if you missed the Discord links, that's all on there as well. But if this inspired any of you, please come talk to me afterwards. I love to talk about this stuff and love to hear your ideas. Thank you again.